Hello everybody, welcome to another C++ tutorial. So today I just want to start putting a few of the things that we've been through together. We're going to make a little game, but I wanted to first mention that something that I think about anyway, and that's that coding is really easy, but programming something is not. And I just mean that it's easy to know what cout does, or int I equals 3. It's easy to know things like that, but sort of knowing how to put the things together and actually make something, actually make a complete application is extremely difficult. And it just takes practice. So you've really got to sit down and practice. It's fun practicing, but it is, it takes a long time. So on that note, let's make video games. Okay, this is the best way to practice. Best way I know of anyway. So the game that we're going to make is fairly basic. It does show, however, the exact same patterns that you'll see even in the biggest budget games, your World of Warcraft or your, Need for Speeds or whatever game really. The biggest games in the world use exactly what, the same patterns as we're going to go through. So, programming games and programming applications is basically the same thing, strangely enough. An application is just a game with a really boring objective. Yeah, kind of. Anyway, games are all the same. So this is the basic game loop. We get input from the player. That's sort of read the keyboard or read where the mouse is or read the controller. Then we update the world, which means that we figure out what all the enemy AIs are supposed to be doing, the NPCs or non-player characters. And, we help all the blocks to fall down if they're in mid-air, or we do the physics. Then we draw the graphics. And we repeat those 3 steps over and over again. So there's another couple of things you might want to do. Maybe you've got sound in your game, you might do that in the update world part, or maybe you'll do it after draw graphics. But basically, from a really broad point of view, those 3 steps are in just about every game. And they're almost always in that order as well. But you can change the order, so there's no real hard and fast rules. And the game that we're going to make at the end, I've actually changed that order a little bit. But usually you wouldn't. Usually that's the order that you want to stick to. But whatever works for you, really. Yeah, these aren't hard and fast rules. They're just ideas to help people sort of structure projects and programming. Yeah, so the game that we're going to look at, actually I've swapped the enemy AI and the user input around. It just made sense that way, but we'll get to that. Okay, so the game that we're working on today, it's not no graphics or anything, it's just a console, but it's a good game. And it's going to be, the computer will ask you to guess a number between 0 and 100, and then it's going to try and guess which number you're thinking of, and you have to tell it higher or lower. Alrighty, so that's kind of why I had to swap the enemy AI and player input around. It's sort of like the computer is playing a game with you, sort of thing. Yeah, that's a bit weird, but that's kind of what's happening. Anyway, I'll post the source code to this to the website so you can have a look without typing it all out. It's probably not bad practice to type it out anyway, if you like, just because it's good to get used to sort of typing IOStream and cout and, main, and it's good to get used to typing the syntax to C++. Just helps speed things up. Okay, so we're just going to start going through it, really. The variables in the game. Well, first off, I've got to include IOStream and using namespace std, but then I've got, 6 variables in the game, and I've actually put these outside of any function, so they're global variables. They're available to every function, and normally you don't have all of your variables global in a game. People think that's a big no-no, but for this particular game, it's really small, and I just wanted all of the variables to be visible from my functions, so this, I think, is a good way to do it. Yeah. We're actually just using a single file here, so it doesn't actually matter. The bigger games, though, if you make everything global, you're going to run into trouble. Okay, good. Okay, so the main function, this is actually at the end of the file, you'll see in the source code, but the main function, as we know, that's where Windows starts running our program. And basically all we want to do here is present a little menu, and if the user quits from that menu, then it's going to come down here to return 0 and quit the game. Otherwise, if they say they want to play the game, then it goes into the main game loop, just there. That while play game, that's going to continuously call the play game function. can't remember if we did functions or not. Yeah, that's going to continuously call them the play game function. Yeah, until the play game function returns, that we want to go back to the main menu. But the outlying structure of a game is a web of control screens. Yeah, this is really, really important actually. So all of the screens lead back and forth between one another for things like settings and main menu, save and load game. These screens are actually not the main playable part of the screen, and most users would probably just forget about them, navigate through the screens and try and get to play the game. But these screens are also extremely important, and if you make your whole game without implementing sort of, I don't know, a little splash screen at the start or a menu to ask where the user wants to go, you'll find that it's actually quite hard to add these screens afterwards. Yeah. Yeah, that's the main menu just there. So this is the first thing that comes up. It just says welcome to the game, and then I've got one of those infinite loops, but we know that it's not infinite because there's a bunch of returns down here that actually break out of the loop. Yeah, we present a little menu, 1 for play or 2 for exit. And playing the game. Okay, so once they say that they want to play the game, it comes to this, and this is the main playing the game loop. Shows a story, then it resets the game, and then we've got the actual main play loop or the main game loop here. So this play game is sort of the main game function, but the actual game's loop that repeats over and over again is right here. So we see update world, draw graphics, get input. Update world, draw graphics, get input. Update world, draw graphics, get input. I'm sure you can see the pattern. Until the user hits Y, which means that they want to quit. Fair enough. And when they quit, we show them the game over screen. And that's pretty much how the main game loop works. Yeah, usually you'd have get input at the top, and then you'd update world, then draw graphics. But as we went through before, I want to do things a little differently. Put get input last. Okay, so the story. I've not actually made a story for this game. I mean, there's no real story going on, but this is just another one of those sort of spacing out screens that you want to put in certain places. So the structure of your game is really important as well. There's a lot more to a game than just that game loop, and you'll often need things like, do you really want to quit the game screens, or maybe a HUD, heads up display. Maybe you need a settings screen, and all of those screens, they should be added at some early stage, not at the end. You should sort of think about which ones you think you're going to need and add them at the start. You don't have to finish them, just add kind of basic screens, like this kind of thing pretty much. I thought maybe there would be a story in my game eventually, so I made this little story screen. Okay, so resetting the game happens straight after the story, and all you want to do here is basically restart the game, all I've done here is actually made the AI set itself back to the default, which is the lower bound of 0 and the upper bound of difficulty, which is 100 plus 1, and reset the user's input to N. Yeah, that's pretty basic. Okay, so updating the world, controlling the enemy AI. Okay, you're versing the computer in this game. I suppose you're probably trying to think of a really difficult number for it to guess, but, it's going to guess it anyway. This is pretty basic as well. We've pretty much got my guess equals lower bound plus upper bound over 2, and that's actually going to keep getting closer and closer to the number that you're thinking. So long as you're honest when you tell the computer if it's higher or lower. If you lie, it's going to know that you cheated, and it knows that when its last guess equals its current guess. Yeah, it says you cheated, then quits. Yeah, fair enough. So this AI here, you might sort of look at that and say, well, that's not artificial intelligence, that's not AI, that's just a stupid trick. But that's exactly what AI is. It's a trick. Yeah, the computer can't think. It's all tricks like this. So this little algorithm just here will make the computer seem like it's trying to guess your number, even though it's not. It couldn't care less what number you're thinking of. But it seems like it's trying to guess a number. Yeah, that's the trick to AI. It's a good topic. Anyway, drawing the graphics. So this is pretty basic, really. We've got no graphics in this game, but I used the drawing the graphics part of the loop just to print out a little menu. So the computer says, I think, and then it tells you what number it's thinking, and then you get a choice to type L for lower, or H for higher, or Y for yes, you guessed the number. Reading user input is pretty basic as well. We just read a character from the user. That's the L, the H, or the Y that we had on that previous screen. And then we act accordingly. So if they type L, then we update the upper bound. If they type H, we update the lower bound. Otherwise, if they type yes, then the computer has guessed what your number is, and he's happy. Yeah, this is an extremely important function. So this is a really common use of switch as well, to put it in the function that acts on the user's input. So here we get something from the keyboard, and we use switch to do the deal with the different options that could possibly be typed in. And the game over screen. So this is another one of those sort of screens that just spaces everything out nicely, makes it feel a bit more professional. You know, you don't want to jump straight from the player dying to the main menu. You want to kind of have something in between there that says, you know, you did really well, you're a really good player, please play again. Otherwise players feel a bit sad and they quit and they go and do something, you know, outside. But this screen happens when the number you've when the computer has guessed your number. And that's about it. So I'll put the source up on my website, and you needn't type it out. But the game's paced okay, I guess. It could be a bit better, but I don't know, it's pretty good for a little game. Maybe 120 lines of code or so. And the AI, I think, yeah, I'm not sure, but I think that's about the fastest algorithm you can possibly get a computer, to play this particular game. If you change the difficulty variable at the top of the code, you can make the game easier or harder. So you could make it guess from 0 to 1,000,000 if you wanted, and I can pretty much guarantee that if you change that up to something like 10 million, the computer will always guess the number quicker than a human would. Yeah, if you play the same game, with the same number, if you play the same number with a human and with a computer, I think the computer will get there faster. Anyway, make games. They're really fun, and they're an excellent way to push yourself and learn programming. So before we go, I just wanted to play that little game. Here it is here. If I just sort of slowly scroll through so that maybe if you don't go to the website and download it, maybe you can type it out from here. Yeah, so that's it. It's just the code that we went through in the slides. And this is what it looks like. Welcome to the game. Okay, once upon a time you thought of a number between 0 and 10. Let me think. I always like the numbers. I always like the number 3. Oops. Have you got one? Yes. Yes, I've got one. I think it's 5. Am I right? No. My number's 3, so that's lower. I'll hit L and enter. I think it's 2. Am I right? No, it's higher than that. I hit H. I think it's 3. Am I right? Yes. That was pretty good. Play again. No. Exit. Okay, so that's the game. This is the variable just here, difficulty. So if we change it up to something like that, the computer's going to get pretty good. Got one? Yes. Okay, if it's 3 again, then we just say lower, lower, lower. 62,000, it's going to take forever. Anyway, that's the game, and that's just a basic introduction to the way a game loop works and the basic structure to a game. Thank you for listening. See ya.